or reflection technique. Very simple. You will send some signal to the target, and then you will receive the reflected signal. Note the time it takes, and you will know the speed of the signal. Then simply use the formula, general formula, velocity is or speed is distance by time. You are supposed to know the speed of the signal which you are sending. Maybe it is a sound signal, or maybe it is some kind of light or radio waves. In olden times, people just to clap hands, it will go and get reflected. Knowing the speed of sound, they determine the distance of some mountain or something like that. That is the basic principle of reflection technique. Suppose if you want to determine, say, the distance of a mountain, provided the environment is favorable, if you want to determine, say, the distance of a mountain, that's what people did it in older times. You just clap the hands or make some sound, shout or something. Then the sound will go, get reflected and reach your ears. Measure the time gap. If you know the speed of sound, speed is distance by time. Use that to determine distance. But now we use somewhat sophisticated instruments to determine time and other such things. So this is only a schematic diagram. Okay, this is a transmitter of some signal. Signal may be radio waves or ultrasound or anything. There is a target. The target may be a submarine. So you will send the signal will get reflected and reach the observer. Actually, transmitter and receiver will be in the same part of the same device, maybe in the same place. So the instrument will have both transmitter and receiver. So you will beam your signal towards the target. It will go at distance. Let's say the distance of the target is d. So the signal will go and come back. So 2d is the distance, d and d. Note the time. Then use speed equal to distance by time. Distance is 2d, not just d. In the case of sonar, the signal is ultrasound or ultrasonic sound or ultrasound. In the case of radar, the signal is radio waves. Sometimes to determine the distance of moon, we can use we can even use laser, which is a special kind of light. So let t be the time taken between the transmission of signal and its reception. Then v is total distance by time. Velocity is distance by time, no general formula. Here total distance 2d by time is t. We want to determine distance. So d equal to 2 times into v by vt by v into t by 2. So you know v. You're supposed to know, then otherwise you can't do. Okay. So v into t. T is experimentally determined. What you experimentally determine is this t only. V is known quantity. Multiply, divide by 2. That will be distance. Okay, this is only a schematic diagram to explain what signal, where is target, and all those things. Okay, just copy this. Now we will do a simple problem. A sonar. This is a textbook problem. The expansion of sonar is sound navigation and ranging. It's an acronym. Sound navigation and ranging. Shortly, sonar uses ultrasonic waves to detect and locate objects underwater. In a submarine equipped with a sonar, the time delay between generation of a probe wave, between signal, dipole signal, it is here he is saying probe wave, and the reception of its echo after reflection from an enemy submarine is found to be 77 seconds. He says T is 77 seconds. What is the distance of the enemy submarine? Also speed of sound in water. 1450 meter per second. Can you just try quickly and give the answer? Express your answer in kilometer value, kilometer units. Simply this one only. Of course, you did it correct. B into T by 2. This one into this one by 2. This is 825 meter. Round it off as 55.8 kilometers.